So here we go with the third starter for chapter 2.2, sketch f of x equals 2x minus 1 minus 3 and label all the points where the graph intersects the axes. So like so much of the graph sketching work, it's probably best to build this up in phases. And the key thing is to keep track of where you're at. So I'm going to do a number of little sketches before I get to the first one. So I'm fairly confident that I can sketch 2x minus 1 fairly quickly. So the first little bit, I could write 2x minus 1, and these are really just little notes to myself, not my answer. 2x minus 1, well, that's going to go through minus 1 with a gradient of 2. When I take the modulus of that, I know that the negative part reflects. I could have done that as a separate graph, and if you haven't got different colours, it's probably easier to. So we've got that bit, reflect, and so the minus 1 gets reflected to 1. So that graph is now the modulus of 2x minus 1. And now, lastly, my answer, I know that the minus 3 is a transformation 3 downwards. So the graph is now going to look like something like that. If this point was 1, it's going to be coming down here. If it's moving down 3, it's going to be at minus 2. So draw it and then worry about labelling. So that's minus 2 because we've moved down 3 from the minus 1 due to the minus 3 here. Okay. What other points? And it says, and label all the points on the question, label all the points where the graph intersects the x-axis, the axes. So I need that one, which I've already got, that one, and I probably ought to label the turning point as well, even though I didn't ask you to. So, best way to find the turning point is probably to come back to this graph, because we know it's the point where it crosses the axis. So we can let 2x minus 1 equals 0, so x equals a half. So this point here will be a half coming from over here. Yeah, so we could highlight that. So there, gave us that. The minus 3, the moving down 3, means that this point over here, it was on the x-axis, so this is now at negative 3, because it's moved down 3. Okay. Now, we've got to find the other 2 points of intersection, the roots. So, we could approach this in different ways. First of all, we could go back, probably is the easiest way, to go to our original equation, and we know, if we call that A and B, at A and B, f of x equals 0. So I've now got 0 equals the modulus of 2x minus 1 minus 3. And as often when we're solving these things with modulus signs in, we need the modulus of the function of x on its own. Yeah, really helpful. So we add the 3 across. So 3 equals the modulus of 2x minus 1. And if you're getting used to these, we could draw that out if necessary. But hopefully you can say, well, 1 happens when 3 is equal to 2x minus 1. So we get 4 equals 2x, x equals 2. Or 3 is equal to the reflection of this. Yeah, so in effect we're now looking at this part of the line after the reflection has occurred. So we've got 3 is equal to the negative of 2x minus 1. Reflect in x-axis, and now we can solve it. So 3 minus 2x plus 1, subtract the 1, 2 equals minus 2x, x equals negative 1. And there we can now label these. A is at minus 1 and B is at 2. There's our origin, and that's x and that's y. I hope that's clear.